Hi, my name is Eliana Seaman, and this is my presentation on the chemistry of coffee. So, what is coffee? Coffee comes from the seeds of plants grouped in the Coffea genus. These include Coffea arabica and Coffea robusta. The word coffee is derived from the Arabic word kala, which means wine or other beverages. A coffee bean is a seed. It is typically dried, roasted, or ground. Once the seeds or beans are ground, they are put into coffee. If a seed is not used in the coffee making process, it can be replanted and grown again into a tree. The fruit that contains the seed is called a coffee cherry. There are over 70 species of these coffee trees. However, there are only 3 main species that we use, which is the Arabica, the Canephora, and Liberica. The Canephora and Liberica are under the Robusta species. The coffee trees are indigenous to Brazil, Ethiopia, India, Indonesia, Mexico, Nepal, Guatemala, Sri Lanka, and Vietnam, but it is said that they were first discovered in forests in Ethiopia. So, a brief history of coffee. Like I said, coffee can be traced back to forests in Ethiopia. One legend is about Kaldi, who was a goat herder from Ethiopia. He was watching his goats in the fields, and they started eating the berries from the trees. And he started noticing that the goats were extremely energetic and were running basically around in circles, and they were so full of energy they couldn't fall asleep at night. So Kaldi went to the local monastery and told the leader there, and the leader decided to use the berries to make a drink, and it allowed him to stay up during the long hours of evening prayer. After that discovery, he started sharing his findings, and not coffee, but a similar kind of drink that they used the green beans for, started spreading around Ethiopia. The actual trade and cultivation of coffee and the actual drink of coffee began on the Arabian Peninsula. The Yemeni district of Arabia started using the coffee beans in the 15th century, and by the 16th century, Persia, Egypt, Syria, and Turkey had also started cultivating the coffee bean. While tea was still the dominant beverage of 17th century Europe, coffee had also started to make its breakthrough, especially since the Boston Tea Party occurred and the taxes on the tea, and the popular bitter beverage was spreading all across the globe. So, harvesting and importing of the coffee beans. So, America alone imports almost $6 billion worth of coffee. In second place, not even half, almost half, Germany imports roughly $3 billion worth of coffee. So, the countries that produce the most coffee are Ethiopia, Colombia, Indonesia, Vietnam, and Brazil. Brazil definitely comes out on top with around 300,000 coffee farms across the country, and it produces over 1/3 of the coffee of the world's coffee. Brazil also produces roughly 50 million 60-kilogram bags of coffee in a single year, and no other country even comes close to that. So the harvesting aspect of it, coffee cherries can be handpicked or picked by machines. Handpicking is definitely more tedious and more expensive. However, it allows for the better cherries to be picked and the leaves or sticks to get into the mix like it would with machines. If it is picked by machines, then they will go through a second machine that will get out the sticks, leaves, or any rotten cherries that have been thrown into the mix. There are 2 separate processes that the cherries will go through after they're harvested. It's either fermentation or drying. So both will go through drying, but if they are going through fermentation first, they're put into fermentation tanks, and that will allow for the outer layer of skin to be taken off the bean, or the green bean as it's called, and then they will be set out to dry for a couple days, and they will be raked continuously, as in the same thing in the drying process, but the only difference is they will be left out for multiple weeks to make sure that the outer layer is completely dried and scraped off. They can't go into the roasting machines until there is less than 11% water or just liquid in the beans. So the roasting process and the Maillard reaction. The roasting process is what produces the aromatic beans seen in stores and cafes, restaurants across the world today. So the grain beans are placed into roasting machines in the importing country. That's really important that the beans that are imported into the country are roasted there, not in the countries that they're harvested in, because as soon as they're roasted, they want to get them out to the consumers as soon as possible, just for better quality, and it's seen as better tasting if they are fresh out of the roaster. After different chemical reactions and changes in the chemical makeup of the beans, they will come out as the well-known brown coffee beans. So some of the chemical changes that they'll go through are part of the Maillard reaction, which is actually a series of multiple reactions. The ideal temperature for most roasting machines is around 550 degrees Fahrenheit. However, they aren't put in at 550 degrees Fahrenheit. They'll slowly reach up to that temperature, allowing for the reactions to take place as they slowly increase to that temperature. The Maillard reaction was discovered in 1910 by a French doctor named Louis Camille Maillard. It is a combination, like I said, of many chemical reactions that occur throughout the entire roasting process. The amidori rearrangement is a process that the compound glycosylamine will go through that will change its structure, and then it will go through one of three processes. It can break it down into smaller chain molecules, an example being the compound used to make butter-flavored popcorn, which is diacetyl. Another path it can go down is losing more water molecules and becoming a caramel-type molecule, and lastly, it can react with more amino acids. Actually, all three, so any of the compounds after the Maillard reaction or in the Maillard reaction can go and react with even more amino acids to create the melanoidins. And melanoidins are the molecules that create the dark brown color of coffee and also the signature taste of coffee, like bitter, roasted, burned, bready, stuff, things like that, but they're more on the bitter side. So around or above 284 degrees Fahrenheit, the rate of the Maillard reaction becomes more significant, and after the temperature reaches 338 degrees Fahrenheit, the caramelization will begin to occur. Pyrolysis is another type of process that occurs in the Maillard reaction, and this will occur when the temperature reaches around 400 degrees Fahrenheit in the roasting machines. It is said to be the heart of roasting, since it is responsible for creating unique scents and flavors of the coffee we drink. When pyrolysis occurs, the beans begin to turn brown, and the sweet and fragrant oil trapped within the beans is released. This is one of the main reactions in the Maillard reaction, and like the reaction before with amino acids and the melanoidins creates the more bitter taste, pyrolysis will release the more sweet flavors. So these are components and compounds found in coffee. Volatile compounds are organic compounds that evaporate at room temperature. They create signature aromas of coffee. Some examples of this are furan and pyrazine. And while those are the two main ones, there are over 1,000 found in a cup of coffee. Now, some acids found in coffee are citric, chlorogenic, punic, malic, formic, acetic, lactic, tartaric, pyruvic, and many others. Chlorogenic are the most common, and I'll talk about it later, but it is also an antioxidant. Grain beans have a higher acidity than beans that have been previously roasted, because the roasting process kind of takes out the acidity. There are also broken down amino acids are also used in Maillard reaction, like I said before. The acid in the coffee helps cut through the bitterness. It's surprisingly, because you think acid creates more bitterness, but it actually cuts through the bitterness and the sweetness and helps balance out all the flavors. So lipids in coffee are called coffee oil. The coffee oil contains fat-soluble vitamins and volatile compounds as well. It contributes to the texture of the brew and how the coffee feels in your mouth. It makes up the crema, which in that picture It's the top layer normally on the espresso. The most predominant fatty acids are linoleic and palmitic acids. But diterpenes are also included in the lipid grouping, and then catechol and choline. So antioxidants, like I said before, the chlorogenic acids and melanoids, which are the compounds that make up the bitter content taste in the coffee and the dark brown color. The antioxidants just work to deactivate the oxidants. More components and compounds. Proteins, the amino acids are used in the Maillard reaction. The common proteins you'll find in coffee are alanine, GLUT, ASP, and H2 proteins, and asparagine. There are a lot of proteins found in the naturally occurring green beans inside the cherries, but again, going through the roasting process and just everything taking out the outer layer will take away a lot of the proteins. Actually, it's less than I think it's 0.5 grams in a whole 8-ounce cup of coffee. Carbohydrates, there are also very few. There's sucrose, fructose, and glucose, and those are going to be used in the Maillard reaction as well. Most of these components and compounds are used in Maillard reactions. So alkaloids, these are the most predominant compounds and components found in coffee, and those include caffeine and trigonelline. So they stimulate the CNS, central nervous system. Trigonelline starts to decompose at temperatures around 160 degrees Celsius. So that means nearly half of the trigonelline present in a coffee bean is lost during the roasting process. The decomposition of trigonelline produces compounds such as nicotinic acid, methyl esters, methylpyridine, and amylase. So caffeine. Caffeine is a purine alkaloid. It contributes to the strength, bitterness, and body of coffee, and it can be found around 60 different plant species. Caffeine can stimulate the CNS, increase blood circulation, and encourage better respiration, and it increases motor activity, creates reinforcing effects, and induces arousal. As we all know, it also plays a great part in keeping you awake and keeping you active. It energizes you and pushes you to get through the day. So here's some harmful side effects of caffeine. It is a psychostimulant that can, although not nearly as extreme, have the same effects on the CNS as other psychostimulants, such as amphetamine and cocaine. Effects of caffeine can include physical dependence, also addiction, withdrawal, and increased tolerance to caffeine. Children or young adults who consume caffeine on a daily basis may experience addiction or physical dependence. Tolerance. So tolerance may not seem as extreme in caffeine, but tolerance is basically your body kind of getting used to the amount of caffeine that you're putting in, and either the effects not working as well as they did before, or just kind of leveling off and not giving you the boost that you really need. This can cause people to drink even more caffeine, which can be seriously damaging to one's health, especially if you're drinking over 400 milligrams or 4 cups of coffee a day. This is also really harmful caffeine in general is just harmful for the younger generation. Younger people who consume caffeine on a daily basis and then stop can have very harmful emotional, behavioral, and cognitive consequences. While withdrawal seems like a very severe consequence of drinking coffee, it has only been found to occur in the most severe cases, or in younger individuals who are still growing and maturing. That is why it is important for the younger generations, their brains are still growing and they're still learning, for them to make sure their caffeine intake is at lower levels than adults. Coffee's health benefits. So the EFSA, or the European Food Safety Authority, claims that intake of 400 milligrams of caffeine per day is not harmful to the average non-pregnant adults. As for women that are pregnant, they say that 200 milligrams is a pretty okay amount for these women to drink. Caffeine has also been known to improve alertness and attention and enhance physical performance. That's why you'll find it in some sports drinks and protein powders that people will drink before they go to work out. It can decrease the possibility of mistakes during nighttime shifts and late night drives. It can help you focus during those late night shifts and make sure that you're paying attention to your driving.